Okay, example 3. Final for critical regions. Here we go. We're going to flip a coin 50 times because we bored in lockdown to test whether it is unbiased. So they're not saying here whether it's less likely to give heads or tails or more likely to give heads or tails. So my hypotheses here would be, this is a regular coin. And alternative would be, it ain't a regular coin. Don't know which way it's biased towards though. They haven't said. Find the significance level of the decision rule. And the decision rule is conclude that the coin is biased if X is the number of heads. So if you get less than or equal to 19 heads or more than or equal to 31 heads. So again, set this out as standard. Sorry, I need to get my answers here that I prepared earlier. Set this out as standard. So we count in the number of heads as our test statistic. Number of heads. I need to get a better stylus. It's definitely not my writing, it's the stylus. I'm going to flip it 50 times. Boom, 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 boom. Probability of getting heads is 50. So I would expect then, my expected value, number of X's is 25 on average again. You can flip a coin 50 times if you want, if you fancy it. Just go do it now. I would expect 25 heads. They have given me the decision rule. So what significance level are they actually working at? What is the probability of landing in either of these regions? What is the probability of getting less than or equal to? What is the probability of their cut-off point? Notice this is not equal to. So it's two-tailed, it's two sides. It could be less or it could be more, we don't know. But because in their decision rule they have already given the two regions, they've said, oh yeah, it could be, notice that's 6 below what I'm expecting, and that's 6 above what I'm expecting. So basically, if it's 6 out either way, so they've taken into consideration the less than and the more than, so I don't have to do the 2 times here, because they've considered it. That actually comes out as 0.0595, and the other one is 0.0595 because it's the same distance away from the mean. That is 0.119 apparently. That's an 11.9% significance level. So basically they're saying, yeah, we are going to say that 11.9%. Anything less than that is too unlikely. So if you get 19 heads out of 50, then we would say that, okay, that's probably a biased coin. Part B. Using a 5% significance level, what conclusion should be drawn if 32 heads are obtained? Okay. So now then they've changed the significance level, so be careful here. We're not working with the same decision rule, because with this decision rule, 32 heads, straight away, yep, rejected. But this is at an 11.9% significance level. They want to say at a 5% significance level, be even more certain. Some will give something even more unlikely. So again, now then, this is basically just a standard hypothesis test now. I'm saying, right, I've got 32 heads at a 5% significance level. Can I reject H0? I don't know. It's not equal to, so it's 2 times. And the probability of X, I'm expecting 25. I got 32, even more extreme, so greater than or equal to, further away from 25 than 32. And that apparently comes out as 2 times 0.0325, I think, which ends up being 0.065, which is greater than 0.05. So therefore, not enough evidence to reject H0. I'd probably say something as well then. We must conclude that the coin is not biased. So we can't reject H0, which which is that it's just a regular coin. So we have to accept that it's just a regular coin, or we can't conclude, there's not enough evidence to suggest this coin is biased. There we go. So importantly then, the probability of your critical region, your decision rule, the probability of your critical region is your significance level. That's important. So the probability of your critical region is your significance level, because your critical region is just the sample value where you start rejecting H naught, and your significance level is the probability where you start rejecting H naught. So the probability of your critical region is your significance level. If they ask you to work out a significance level, then you just work out the probability. And again, if they say, oh, here's the significance level, find a critical region, like in this example, 5% significance level, well, you need to find then the first value, so go more extreme than your expected value there. Find the first value that would lead to rejecting H naught. Oh, there she is. So technically, in this first example, our significance level isn't 5%, it's 3.74% technically, because I can't get a value of 5% dead on. But 4 is 9.79%, and 3 is 3.74%. So technically, it's a 3.74% significance level. It can be even more strict than 5%. So I've only got a bit of a 3.74% uncertainty there. Yeah, okay. Anyway, thank you very much. Get doing some exercises.